Okay. This is the definition of a tough act to follow, or from the sublime to the ridiculous. One thing that occurred to me in doing research for one of the previous ones I've done, Dr. Mann talked about, she showed a picture of who's the bunch who took all the radio astronomy and generated the radio image of the event horizon of the black hole. Yeah, that. They did the same thing, or maybe that's the one I was thinking of, for the massive black hole at the center of the Milky Way. It has approximately 4 million solar masses. So 4 million times the mass of the sun, and the estimated radius of it is about 50 million miles. It would fit just inside the orbit of Venus, inside which right now, here, we have one solar mass. Pack 4 million of them in there, and watch your whole physical concept go weird. The reason there's only two things that matter about a black hole is you can't do physics inside one. It's same as dividing by zero. It's like, who knows? It all goes weird, and we can't do it. So, as I say, now on to the ridiculous. Okay. Four things. This is kind of a slow month because, well, we'll find out. That's point number 3. Comet 12P Pons-Brooks, which is not nearly as cool as Neowise a few years ago, or Hale-Bopp, or any of the really, really cool ones, but it's what we got. It's sort of approaching Jupiter in the sense of like that. It's not there, but it's in line. There is a conjunction of Mars and Saturn in the morning, which actually happened 2 days ago. But it's still, they're close. It's tough because you got to look just before sunrise. And where are all the planets? Good question. And the Eta Aquariids, I don't know why they put 2 eyes next to each other in Latin. I would like to go back in time and fix the way they spelled words, and it drives me nuts because I learned from an old friend of mine that the correct name for a Douglas fir, it's a false fir. It's Pseudotsuga menziesii. 2 eyes on the end, I think. I'm never going to pronounce it that way. So that's not what I wanted. Come on. There. As of today, that's a screen capture from heavens above. Now, you notice our nice little sun over here set against the black sky. Well, that's fantastic. It's right next to Jupiter. The aphelion is out about where Neptune is, 33 plus AUs. Period 70 years, eccentricity big, and tipped to the ecliptic. So its angular velocity, as Dr. Mann was referring, is different from the main plane of the solar system, which tells you It's from way out there eventually. That's where it came from, because it's sort of Brownian motion out there. And it's preserved that. Now, if you zoom in, like I say, I've never seen Uranus in a telescope. I've never been able to find it and know that's what it was, because my setting circles on my scope aren't that good. I don't have a go-to button, and it's star hopping. It's kind of beyond me. Anyway, possibly might be able to see the comet, Jupiter, and Uranus, which would be a threefer. We'll see. And here's why. For April 20th, you can see the comets down here. This is a stellarium screenshot at 9 p.m. You can see Jupiter and Uranus up there. This is 10 degrees above the horizon. So this is 5 and change, which is there above the western horizon. You're looking through an awful lot of atmosphere. And it's bright, and comets have a low, they're certain brightness, but it's distributed, so they don't stand out. Iffy, really iffy. However, I'll give it a try. And it is amazing what you can see with binoculars. The moons of Jupiter, Uranus will certainly be bright enough to see. Now, this is the problem for me. It just looks like any other 5th magnitude object out there, unless you've got good magnification and a really dark sky, and you can see it's a disk now and pale green instead of twinkly like a star. That's the hard part. Anyway, it's something to do. Here's another something to do. This is tomorrow morning, 6 a.m. And you got Mars and Saturn out there in the east. And that is right between east and southeast. So it's east-southeast. They're both about the same magnitude, but of course the sun's just about to come up from the lower left here. So if you can find them in binoculars, you'll be able to distinguish them. The cool thing is they'll be a different color. Saturn's going to be a paley, creamy yellow, and Mars, of course, looks reddish. And this is cool, 36 arc seconds, including the rings. Although it's pretty much on the other side of the sun, so you're not going to get, especially at a low angle, really good resolution of the planet, the rings. You won't see all the gaps and stuff. You may see Titan, but it will be interesting. So, where'd all the planets go? Well, with stellarium, you can remove the atmosphere and make the Earth transparent. Click, click. There goes the atmosphere, and there goes the horizon. And if you look in the right place, and you put the ecliptic on, and it becomes really obvious why it was invented. You've got Uranus and Jupiter down here. So that's east of the sun. So there's the horizon at night, and they're following the sun down below. Venus and Mercury here. Mercury is doing this around the sun. Venus has done that around the sun from way out over here. So it's headed behind, and Mercury is still going around. Mars and Saturn are out there. We're catching up to Mars, and we'll catch up to Saturn. And you will notice this. That's the radiant of the Eta Aquariids Meteor shower. So that's where all the planets are, and they're all too close to the sun to see. So
That's okay, it's raining again.
Well, we're in apparently for a stretch of good weather, which is lovely. And I had a lot of fun last year just with a pair of 8x50 binocs, getting out the chart and trying to find Messier objects in the west. And yeah, you can see it's M13 in Hercules, right?
Messier 13.
Yeah. I got M22, I got a bunch of them in Sagittarius, and it's like, you know, when you really get dark adapted and the neighbor's motion sensor light isn't on, you can see an awful lot. So it is way cool having a dark sky, which we tend to here. So that meteor shower, the peak is local noon, May 5th. But it tapers off to 50% over about a 5-day period, which is somewhat spread out. It's not like a really tight little ball of dirt that goes, and that's it. So you got a few days on either side. And the ZHR zenithal hourly rate is about 60. Perseids is about the same. The one in January, yeah, then I think is 90.
90 to 100.
Yeah, somewhere in there. So you got a shot. The problem is, you don't, it's a waste of time trying to do it when the sun's coming up because it washes them all out. Now, the neat thing about this, and this is why I like stellarium so much. What is that object up there? Above Saturn and definitely off the ecliptic. That's the International Space Station setting in the east. Because it rises in the west and sets in the east. Now, if you want to see the space station, and personally, I think that's really cool. Yes, it's light pollution, but it's really cool. And as I've mentioned before, I applied at the same time as Chris Hadfield. They picked him. Well, I play a piano and he plays a guitar. I'm sure that was it. Because, you know, £3 for a guitar piece of cake. They're not shipping a baby grand up for me. So anyway, check Heavens Above for the times, because the space station drops all the time due to drag in the thin outer atmosphere. And then they boost it back up. So it changes the orbit routinely every week or two. They're changing it a bit, and that affects the times you can see it. But it is cool to watch. That's all, folks.